All right, this lesson here is on measures of dispersion. Measures of dispersion looks at a few things starting with range and interquartile range, but also looks at quartiles, medians, and how range can be spread out or really clustered together. And that's what we want to look at. Most of the time, you will see this paired with a box and whisker plot because a box and whisker plot is a data display or a graph that can show dispersion very well because it splits all of it into equal quarters of 25% of the data, and if the data is closer together, that quarter will be small, and if it's more spread out, the data will be further apart. Let's just start with this first one here, looking at just what range is. The range of a data set is the difference between the smallest and largest values in the set. How far does it go from one to the other? Find the range of the following data set. Now, they made it very, very easy for us because they put it in order from least to greatest, giving us our minimum and giving us our maximum. It won't always be done like that, so always double check to make sure that you have the smallest number and the largest number, our minimum and maximum, before finding their difference. And we'll simply take the min and max and we will subtract them to find our difference. In this case, our range is 24. Let's take a look at the next question. Now if we want to split up our data set into quarters, all right, we will use the term called quartiles. Data can be separated into these quartiles, each of which contains 25% of the total data. The first quartile is the median of the lower half of the data set, and this is also known as the lower quartile. All right. The second quartile is the median of the data set and will actually often be referred to as the median. The third quartile is the median of the upper half of the data set and is often referred to as the upper quartile. Now, when we say the upper half of the set and the lower half of the set, what they're referring to is the split where the median cuts it in half. And everything less than the median is part of the lower half of the data set. So that's less than the median. Everything greater than the median is part of the upper half of the data set. The median is not included in either set. All right, the median is not included in either set. It's the numbers below the median or above the median. The numbers below can be the same as the median, all right, if you have a bunch of the same number in the middle there. However, the median itself is not included in either set. All right, so that's how we split it off. Let's see what it looks like here in an example. If you take a look at their example, if they first started by numbering the orders in order from smallest to largest. If you're given a data set and it does not include an ordered set of numbers, you have to put them in order first. Most of the times you'll have to do that. So please double check. In this case, it's done for us. The median is finding the middle value, and there's a couple ways you can do that. The easiest way is to just mark off a lower and higher number at the same time. So here I'd mark 60 and 90. Then I'd mark the next two, 65 and 87. Make sure you're marking off the same amount on each side and then pausing. Don't just go back and forth. If I mark 2 on the left, I need to mark 2 on the right. All right, so I have to make sure that I'm marking off the same amount on each side, and I'll get down to one number in the middle, one number if your data set has an odd amount of values. I'll end up with 2 numbers if your data set has an even amount of numbers. And if you have an even amount of numbers, you have to add those 2 numbers and divide by 2. Let's just pretend for a moment that the middle numbers were 78 and 80. All right, I'm just pretending. That's not actually the case here. But I'd have to add them together and divide by 2. And when I did that, I'd find that 79 was the value right in the center of those 2, making that the median. So if you have an odd amount of numbers in your data set, you're going to get down to 1 in the middle. All right, so once we find that median, that marks our median. And notice here in the next set that that median now separates the upper and lower half. The median is not included in either of those halves. Now we take the median of the lower half, known as our first quartile or lower quartile, and we'll again mark off one number on either side, and we'll find ourselves getting down to one number in the middle. Once again, we got one number because there were 5 values in the set, and that's an odd number, so I got down to 1 in the middle. If you have an even number, you'll get down to 2. So pay attention to that. Upper half, I do the same thing, marking off 1 on each side till I get down to my 1 in the middle, and that's known as my third quartile, also known as my upper quartile. That's how we split it out. If we were to draw a box and whisker plot for this, we would create ourselves a number line, and on that number line, we would have equal intervals. All right, and we would just start listing some of those intervals here. I have to go from 60 to 90. So let's just say I'm going to go... I'm going to go by 4s. All right, that gets me all the way up there. And I would mark off these values at the different spots along the way. So 78, I'd put a line for my median. I even like to put 78 right above that. My lower half 70, so that would be right here. And pardon me that I'm not using a ruler. I can't use it on this TV or it really messes things up. 85, well, I notice I've got 80, 84, and 88. 86 would be kind of right in the middle there, so 85 would be about right here. All right, and I'm going to mark that as 85. And that creates my box. My quartiles make my box on my box and whisker plot, with the median as a line in the middle of the box, not always in the dead center of the box, but inside the box. And then I draw a whisker to my upper number and my lower number. So my upper number here, all right, that'd be 90. All right, and then my lower number is 60. And that's how I go about drawing my box and whisker plot, so we can see the different spread, giving me 25% of the data in each section. 25%, 25%. And it's an approximate 25%, because if you notice here, each section has 2 values in it. But if you actually look at it, our 2 values in this set, we actually have 11 values altogether. And if we divide 11 by 4, we don't get 2 exactly. All right. In fact, it's almost 3. We get 2.75 because 3 of our numbers in our set were not included in any of those sections. So again, it's approximate 25%. All right, let's talk about the interquartile range. The interquartile range contains 50% of the data and is calculated by subtracting the first quartile minus the third quartile. The reason it contains 50% of the data is because it's the box. And if you remember in our box and whisker plot, I'm just going to draw it again real quick here very briefly. Our box contains 2 of our quarters. All right, so a 25% here and a 25% here gives us 25% and 25%, total of 50% of the data. What's the range of that box? Well, we said in this case it was 85 and 70, and we want to find the range of that just by subtracting, just like we did the range before, max minus min. Now, interquartile range means between the quartiles range. So I'm just going to take my quartiles and find out how far they go. In this case, 85 minus 70 is 15. All right, that's our interquartile range. Let's take a look now at some box and whisker plots and go from there. All right, taking a look at this box and whisker plot, we actually have 2 box and whiskers plots on this number line. But a box and whisker plot takes the large amount of data and clearly identifies the lowest value, minimum, the lower first quartile. All right, notice they said lower or first quartile. The median, often referred to as the median, but also known as the second quartile, and the upper or third quartile and its highest value. The line drawn through the interior of the box identifies the 50th percentile, or the median of the data. Basically, 50% of the data is above that median, 50% is below. The lines that make up the sides of the box represent the lower and upper quartiles. The lower quartile identifies the 25th percentile, and the upper quartile identifies the 75th percentile. Basically, how far we are in percents. Again, each quarter of our data is represented in here, giving us 25% in this first section, 25 here, and here. So 25%, 50%, 75%, 100% of the data. All right, so that's how it's split up. Let's answer our question here. All right, which city had the higher median temperature in May and by how many degrees? So basically, they want you to identify the median in each of these. Well, take a look at our number line. I can see our number line here is going by 5s. All right, so this would be 45, 55, 65, and that's important because my median right here is at 65. So for Los Angeles, that is 65 as my median. All right, for New York, I've got 70 as my median. So what is the difference between those? Well, which one had a higher median? New York had the higher median, and by how many degrees? Well, it was by 5 degrees. It's 5 degrees more. Let's ask some more challenging questions about this, though. Let's ask about our percents. All right. In Los Angeles, what percent what percent of the temperatures were above 80? All right. What percent of the temperatures were above 80 in Los Angeles? Well, if I take a look, this section right here, 25% of the temperatures were above 80. What percent of the temperatures were above 80 in New York? Well, look at that. It's also got 25%. Even though New York has a longer whisker there, they both represent 25% of the data, which is nice because we know that each section is always a multiple of 25. If I asked what percent of the temperatures in Los Angeles were less than 80? Well, if I go less than 80, that's 1, 2, 3/4 of the data. So that would be 75% was less than 80. Same thing in New York. Same question. What percent of the temperatures were less than 80? Well, if I look, it's 1, 2, 3 sections again, so another 75%. Even though New York's box and whisker stretch further than Los Angeles's, all right, in this case here, we still have 3/4 of our data were less than 80, so 75% of the data was less than 80. They're just more spread out in New York. New York seems to have a bigger range of temperatures in May. Let's ask another one. Approximately what percent of the temperatures in May in Los Angeles were below 65? What percent were below 65? Well, I can identify 65 right here, and I can see they had 2 sections below, so that would be 50% were below 65. 50% is also above 65 because that median represents the split. If I were to ask the same question in New York, approximately what percent of the data is below 65? Can you answer the question? Well, 65 cuts in right here, but that is not marked off by a quartile nor a median. Therefore, I can't give you an exact percentage. All right, in this case, I know that it's more than 25% because this is 25%. And I know that it's less than 50% because this whole thing would be 50%, but I can't give you the value in between there. So it's going to be between 25 and 50%, but I can't give it to you. And so that's not a question that I would ask you on an exam, and that's not one you could expect to be asked. But it's something that you need to know, so if you're seeing something like that, maybe it's asking the wrong question or maybe you're reading it wrong. Let's see if we can answer it. What about above? All right. Well, if I were to go above in this case, again, I know that it's right here, which means I know that more than 50% of the temperatures were above 65 because there's at least 50% that's above. And I know that it's less than 75%, which would be this entire bit, but it's somewhere in between 50% and 75%. I can't give you a more accurate estimate of the data because I don't know. Even though it falls in this section of the box, I could have a lot of the values here and only 1 or 2 here. You have no idea. But I know that more than 50% but less than 75% were above 65 in May.